Hello, everybody, and welcome to today's webinar, Catching Conveyor Degradation Before It Disrupts Throughput. Today, we're going to be learning about why most conveyor failures are detected too late and how leading operators are intervening earlier. Today, you will be in listen-only mode, and there is a Q&A panel located within your Zoom interface that you can pop your questions in. They will be answered at the end. If you have any technical questions, do also pop them in there, and one of the technical assistants will help you. Furthermore, the chat is open for comments and discussion, so please do interact with us on there. Now, you will be receiving a copy of the recording that will be shared after the email, and we'll follow up on any unanswered questions. Now, most importantly today, here are our two speakers. Joining us from Multisensor AI is Luke Graslow, our Director of Reliability and Maintenance Programs. Joining Luke is Séan Allen, who is our Director of Product Management. Both of these are experts, reliability leaders. They come to us from Amazon, and they have a huge amount of expertise around the topic for us today. So I invite you now to join me in welcoming Luke Graslow. Over to you.
Thank you, Alicia. So, Séan, let's get into it. We've worked together for a long time in reliability and maintenance, developing programs and strategies across the asset lifecycle. Our team, while we're at Amazon, reliability engineering programs, we're an end-to-end support function, covering everything from design, working with SMEs, OEMs, and integrators through factory acceptance testing and system acceptance testing. Moving into install, using lessons learned to develop IOQ strategies, detection, building monitoring programs around known failure modes, and then functional failure. The aftermath reporting, feeding into root cause analysis, failure mode effect analysis, and putting them outputs back into design, installation, and detection methods. Material handling equipment made up, 90% of our critical paths. So understanding degradation before it came, disruption was essential, which leads us nicely into kicking this off, Séan. In 2019, in the early days, everything felt like a hard stop, sudden failure. Why do you think this is?
Thanks, Luke. We've certainly seen a change from reactive back in the days then in 2019 and before that, moving to a more predictive, prescriptive environment. To answer your question, I think we can go and split into two avenues of discussion. So that the first being non-engineering variables, so more on the growth of the company at the time, and which is the same as other businesses that we've seen. The scalability. So when you've got hyper growth, you're sometimes moving quicker than you can in terms of the capability within the strategy and within your workforce. So we were launching many buildings quickly at a very fast period during 2020 to 2022. And coming with that, you had a lot of expertise and reliability that were outside of the company. So there was a lot of expertise there, but in terms of heavy industry, if you think about manufacturing, the armed forces, there was a lot of expertise, and that's where we started seeing the change from a reactive mindset through to a predictive mindset, utilizing them skills. So I think certainly the scalability, if you think of the growth that we experienced, lots of different vendors, lots of different integrators. So standardizing the strategy was a challenge in terms of installation and integration. We can also bring into discussion the skill side of it. So we need to load our workforce, our technician level, with the expertise to respond in the right manner for mean time to repair, mean time between failure. And it was a very high pressure environment, so heavily operational with high throughputs, high volumes, a lot of pressure to respond to failures, and that's where we started looking at detection methods and industry techniques that you're showing there in terms of the DIPF curve.
I find it quite interesting, to be fair. If you take that first point, hyperscale, everyone knows when you start doing a lot of something, the first thing to go out the window normally is quality. If you look at most engineering firms and they got that nice little board. If you want something fast and you want quality, it's not cheap. But then if you do something, slow and you want it quality, it can be cheaper. And it's kind of where we saw programs, especially when we were in that hyperscaling phase. We were popping up sites left, right, and center. You know, technicians couldn't scale in time. Training was a big gap, and it became apparent. You know, the quicker we went, quality was going to get hit, and we were going to run into them early failures.
And I think with the scalability in terms of assets, over 1 million assets, I'd say globally, you had to bring some structure and framework to the way that you tackled reliability. So it's not a one size fit all strategy. You've got to be targeted with your failure mode. I think that's when we started seeing the real shift from. I don't so much think it was a reactive mindset from the people. It was just the growth. You ended up in a reactive mindset. You were using OEM based recommendations a lot of the time. And then from that, I kind of had basic maintenance strategies that you had to just activate to get moving. Once that key's turned and the assets are operational, you've got to be maintaining in some way. So we almost flooded the system to begin with a lot of heavy intrusive maintenance that planning and scheduling through the years it got higher with the pressure because the availability versus the labor hours required was not matching. So I think the real shift we seen was criticality assessments. I remember you working on the auto criticality assessment. If you bring them factors in and you score it with the right team, then you've got a really solid ranking, and then you can start really pinpointing your techniques based on the criticality. Is it a single point of failure? Do we have contingency? What is the cost of being down? So that's where I think we really seen the shift in to more of a predictive mindset.
It's one of the points that I always try to keep drumming home when we visit customers. We go out there, and we're not just that software and hardware provider. We want to be a reliability partner, and it's criticality, criticality, criticality. If you're not targeted and deliberate, you just throw money at the wall and hope something sticks. Where criticality is almost when you look at the total of all these programs that we try and implement, we get out there, continuous improvement, all that. If you get criticality right, it's the first domino that needs to fall. Then all these other programs, dominoes, start falling straight after. It's the very first domino that needs to fall when you're trying to do all these programs. But considering, all the FMEAs, root cause analysis you've done over the years, where do you think degradation starts across belts, bearings, drives?
I'll split it again. So strategically, we can think back to the DIPF curve. So if you think of that design phase, obviously the quality of product now, a high scale business, you can't always have the best quality because that means your cost goes through the roof. So you've got to find a middle ground. So I think the quality, the specifications of your material. Has it been quality tested before it comes into the business? That's at a component level, belts, rollers, bearings. But if you think about assets, we really started moving with design for reliability. Like what's the factory acceptance test that you're doing? Even site acceptance tests when it's required. We had strong internal processes, the same as many businesses in terms of that second check and the third check before you go live. So I think there's the design part of that. You can then move into the installation integration. So let's take a belt as example. If you don't tension, track, align your belt from the start, you're always chasing you're chasing your tail. You're starting from a bad point. So that's super important that you get let's call it the standard settings, the parameters correct from the beginning. And we've seen a lot of examples where that didn't happen, and it was for a number of reasons. It was time, it was the acceleration we needed to move at. So I think that the curve's a good place to start. And then obviously your maintenance through the years. So we've mentioned the preventive maintenance in the early years, but we started moving to more of a predictive mindset, and we see things change in terms of downtime and events. So that's more the strategical side. I think there's a good example on the screen there of a root cause analysis. You've got to train your people. You've got to arm them with the techniques to do root cause. There's a fault tree analysis there. There's 5 whys. There's Ishikawa. There's all these different techniques. It's using the right one at the right time, because you can go too deep on an event that didn't bring you down for that long, and vice versa. So I think that's a nice example there. More from a technical side, you can see on the screen now, lots of belts, bearings, motors, and drives in the distribution center networks, and many businesses with MHE. Belts, I've mentioned alignment, but that is one of the key ones. Make sure your alignment's right. Your tracking, you often get belt tracking. If there's not enough tension, you get slippage. Slippage can lead to heat, and that's where thermal can come in. Your edges, you see edge wear. If you catch that structural framework and you fray that belt, then you're quickly propagating it. Abrasive materials, lots of different products going through the process flow. Your joints, you see fatigue there, so that's belt. Bearings, lubrication. Are they sealed for life? A lot of them are nowadays, but how quick does that break down? If it's not, are you lubricating with the right lubrication at the right time, with the right methods? Contamination ingress, that's something that we've seen a lot of. Pitting, false Brunelling, race wear. I think bearings, we've seen a lot of issues with them. Motors, you've got the electrical side of things here, so you've got overheating, imbalance, the insulation, your misalignment again. So I think from a technical side, there's some examples there in terms of targeted failure modes, but it's how you respond. How do you quickly respond? How do you detect in the best methods and avoid that failure?
I think there's a real interesting point here when we look at, condition monitoring was always that in that operational zone. The equipment's installed, everything's going, everything's running, and we're looking at state changes over time. One of the key drivers I tried implementing was using it for installation of quality, so like IOQ acceptance, something's got built. And I think there was a real, like, if we looked at a system like our customers use now, and we could do that at factory acceptance, we can build out them reliability KPIs, like what does normal look like in the factory? So we go, normal running condition is X temperature, X vibration. We've got ultrasound WAV files that we can compare. We've got oil analysis samples for contamination. And then the moment it goes into the building and gets ready for deployment, straight away you've got a cross check. So you're not using masses of labor then to go through and do IOQ visual check standards or check this, check that. You've got quantifiable data to go against. And I think that there's kind of something that's forgotten when we look at condition monitoring. It's for the operational zone. No, it's not. It's a lot of baseline data that can be used during that installation of quality, that commissioning, that understanding. And it was one thing that always used to like blow my mind. You get a factory acceptance test, and there was not one standard in there about normal operating conditions. Not many OEMs even classified the vibration classification against ISO standard. So it was just
I
weird.
I think what you're saying is that it's valuable to do it from that point. We like you said, I've done a lot of FATs and there's things, decibel levels. Yeah, obviously noise is important, but it was very much an installation, like almost a build check, like you're almost doing the second quality check for that OEM, rather than right, how is this going to be operational in our buildings? So I think what you've explained there, and a lot of OEMs, let's be honest, they're mastering their product. They want to be right first time through the production line. They're really high on quality, but they maybe haven't yet got to that point of thinking about what you've just explained there. So yeah, it's valuable for the DFR, design for reliability. I think before we move on, just quickly, that was something that we've seen quite often, that the process flow, the assets can sometimes be procured based on cost, lead time, and other factors. But we've seen a lot of examples where the practicality of maintenance, accessibility, the height that it was at, the clearance between assets, fencing, netting. A number of times we had issues where accessibility was a problem. So I think it's also it's collaborating and merging that kind of design teams with operational teams with engineering teams and being together in the room at the design phase. So it just complements what you said there.
Yeah, it's an interesting one because I always see our time there, and it was, if we look back in hindsight, we were data rich, wisdom poor. We had all these tools, SCADA, OEE, and on systems. And as good as these systems were, I always felt like it kept us in that reactive mindset.
I agree. I think you've got to give credit to SCADA and OEE for what they were designed for, so that they give you that visibility of the process flow from a high level. So, if you think of an operating base where you sat looking at HMIs and screens and something like you see on the right there, then it's valuable because you can quickly go, right, where's this jam in the building? Where's this accumulation problem? How many chutes do we have full? Whatever it's flagging. And you can go and you can investigate and you can diagnose quicker. So from a mean time to repair perspective, then I think, SCADA is solid. Like it's industry wide, but it tells you after the event. So it's not giving you the trend in leading up to through your degradation path to a failure. It's that visibility gap. Like you're not seeing everything from a trending perspective. You're seeing it once it's gone down. So I think we've got to complement these different systems and bring them together and have them placed in the right place. We shouldn't really be using SCADA as a detection method because it's not what it's there for. It's to say, go and look at this problem that's already happened. So I think but like I say, we should give credit and OEE, and again, an industry-wide metric to say, right, okay, what is the overall equipment effectiveness of your assets in the process line, and are you getting your quality, performance, and availability from them? So we'll probably go into some more detail on that. But and on as well, great visual system, quickly see what's happening. You can use it as an indication of you know process problems as well, where maybe your Kaizen will help you get to the bottom of some things. But that's my opinion on them. I think great systems. We're not going to change them, but they've got different places in your day to day.
Uh, See, with SCADA and OEE, and you could talk about your leading and lagging metrics. To me, it was always about that, cause versus effect. What was the cause? And SCADA was always looking at the effect. So, the cause could be that that belt slowed down. So now you've got a jam on that photo wire. It wasn't the fact that, it was a jam. It's just that we've thrown the logic out. So that peck had a 3 second timer. That belt's now snagged up on the side guarding, which has caused a delay in that parcel transition or whatever that is.
Hmm.
Never meant it was a jam. It just means that something else was going on. So that the effect was that, yeah, got a jam. The cause was actually the belt tract, which caused the
Yeah.
delay in the transfer, which then blocked that cell. So I think there's a lot of patterns and systems that are out there that are all about logic control and process path flow that aren't
Hmm.
exactly going to give us that lead in, like what's coming up, what are them micro stoppages, where is it hitting me? So that one big event isn't
Right.
always going to be the hurter. It's going to be these little micro stoppages and these little transfer differences on the PLC logic that are your first initial clues, but they're not. When you get them detection methods out there and you look at that track belt and you got that nice, clear as day hot strip going down the one side, it's so visual, so impactful that you go, bang, I know where that fault is. We're not doing masses of diagnosis. We're not doing massive, drilling down into what the issue. One of the joys of thermography is, we all grew up playing Spot the Difference. Thermography to me is a giant game of Spot the Difference. What's different to then and now?
Yeah.
Which, when OEE is a different kettle of fish. So let's talk a little bit more about OEE, especially for the people on the call that don't know about OEE. Do you reckon you could give us a bit more of
Yeah.
a drill down into that?
Yeah, of course. There's a calculation. So OE is an industry-wide metric which takes into account your availability, performance, and quality. So you can see an explanation there. I'll quickly run through them. So availability, it's measuring whether your equipment is available when scheduled to run. So it's looking at stoppages, so downtimes and failures, jams, changeovers, waiting for labour and materials. I think the point I'd make on that is that the OE doesn't care what's stopping it. I think big engineering failures are always the one that gets the headlines, like a catastrophic sort of crash. We've seen them before. They get the headlines. They really hit your metrics, and every stakeholder in the business is looking at it, which is right, but there's hidden losses within there. There's short idles, there's micro stoppages that they accumulate, and they can be just as damaging to your metric as the big hitters. So I think we should split it, and what we're speaking about in terms of your detection methods, your predictive maintenance, infrareds, everything else, then keep it like way for engineering. But I'll give an example. I came from pharmaceutical. And it was a batch processing plant, which is different to continuous processing. So you were stopping after a batch, you were cleaning down your machines, sterilizing them, because you were flipping products across the SKUs. We had real problems with label reel changes because you had so many different shapes and sizes of labels, but it was things that you would never expect to be bringing you down as much. It was, where is it located? How is it packed? How long does it take to tear that packaging? How does the operator on shift A do it differently to shift B? How do they run the reel? How do they make sure it's connected? And all of a sudden, something that should be a 30-second stoppage becomes 6 minutes. Happens 6 times a shift. And then then micro stoppages are super important. I think it's that collaboration again. It's working with every function and saying, right, we're all accountable for this metric. Let's see what's really hurting us. So some great examples on the screen here. So world class, only prize winning companies have an OE of 85%. I used to be happy with 43% on one of our production lines. Like that sounds ridiculously low, but all the things I mentioned there, seriously, 43% was like, well, we're doing really well.
Hard earned.
Hard earned, yeah. A typical OE is 60%. So I'd 2% by going digital. That's another thing. The amount of clicks you get on HMIs, operators will often click, 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 and you'd get really poor data in. And they're under pressure. They've got to do their day-to-day job. So the data, the Pareto charts, you're thinking this is not true. So automation and all this great stuff we're doing nowadays helps. Don't monitor your OE is around 40%, right? So I was just over the limit in my example there. So yeah, running doesn't mean healthy. That's true, but that's where detection methods come in. If you're seeing frictional heat, the naked eye won't see that. So that's an example we can give there. There's a list which I don't need to go through now, but the lots of different things build up to that OE metrics. I think the final comment on that is don't ignore anything. OE doesn't care what's happening underneath.
I think I tell you, so it's funny you say that because one of the GMs when I was, fresh in, first ever come across OE, I came from a military background originally, weapons engineer by trade. And then I stepped into this automation industry and I learned it from the bottom. And OEE was my first wake up call. And the GM turned around and he was like, "This isn't good enough. What's going on?" And I'm like, "Look, I've worked solid for 2 weeks. I've worked hard. I've tried figuring out everything we've done. We used to do the A3 12-week continuous improvement plans,
Mhm.
and he's just one line hit me hard, and he was like, "Data doesn't give a crap about your feelings. The number's the number."
Yeah.
And I was like, "Do you know what's great?" So OEE does not care how hard you worked. The number is the number, which kind of brings us into that, you know, we look at them non-critical issues and you kind of touched on it, but how do they quietly erode your throughput, your OEE performance? Why is it impacted not just by the big high impact events that them non-critical?
Take an example from where we used to be. We had a certain asset that it would often it would often jam, and if you didn't have an operator in the area and your andon wasn't flagging, then the reset could take way longer than it should have. You could be just after a break and people aren't back in their positions or whatever, and you can't ignore. We can call them non-critical because when you see it as a one-off event, yeah, it's not really a big thing, but it's that word accumulation again, like PLC resets, operator intervention, jams, amnesty jams, whatever. They do erode at you. Like we as reliability engineers or reliability leaders, you're always looking at the top of the Pareto. You're looking at that, what's brought us down, what's lost product, what's a customer miss, whatever the metrics are important to your world, your industry. You typically look at the top of the Pareto when you shouldn't always do that. I think it depends on the data view. Like it's all data, isn't it? If you look at downtime or you look at lost productivity hours, then it's always going to be at the top. But if you look at number of failures, then something different will be there. So it's bringing them different data views in when you're doing your analysis. Like don't always just go down the same avenue. Take different angles, take different opinions, and then you have a more well-rounded view of. I'll call it. Um, you're often at the like 5,000 foot view. You've got to be at the 50,000 and looking at everything that's going on in that process.
Uh, I find it interesting because if I take a flashback now and I look at all the programs and continuous improvement programs that especially our team at the time was trying to do, you're not focusing on that one-off high impact event that was an anomaly or end of year like, the money's earned in them micro stoppages, them right, who's targeting that 2 second loss? That 2 second loss happens every hour. That's way bigger than that one bearing failure that we repaired in an hour, but it's a more talked about event. And I think, I would have loved some of the systems we've got now and that, back then, because when we were trying to look at them micro stoppages and we calculated them out to actually understand gross impact, some of the, oh, it's just a jam, I'll unblock it. Well, actually, it turned out in that single one, that jam happened 9,000 times over the space of a week, which led to six hours worth of downtime. And it weren't until we
Mm.
started creating heat maps with our live condition monitoring programs and the fixed thermal live monitoring, it paints that picture. And when you look at the playback features for root cause analysis, being able to go back in time or CCTV footage and see how that event leads up helps with that, leading back into the D of the DIPF, that design. Like, how do I design this out? Or how do I improve my detection method? How do I make sure I'm getting this better next time? It's imperative.
It really is gold dust. Like it's a much like richer insight. The playback function we mentioned there, as a reliability engineer, it's so important to have that view for your root cause analysis. We mentioned fault tree analysis and Ishikawa, the six M's, whatever it is. You've got to have that raw data, that raw evidence to build these, to even like frame your analysis before you start thinking as an engineer about what's the cause effect, what's the solution. So these kind of things you mentioned just make the life easier of a reliability engineer and other functions within the business.
Kind of brings us back onto FMEA, and you got that point in a failure mode effect analysis that's around detectability.
Mm.
How can you detect it? And I remember I got asked once to do an FMEA, and for those on the call that have done an FMEA, asking one person to do it on a critical asset in a week is ridiculous. I myself and Sean have been part of teams that you look at OEMs, key stakeholders, design from component level, and it'd be what, 10, 20 people, and it'd
Yeah.
be months and months of work. Just I remember you saying when we met once for one of the key vendors at the time, and you must have been doing the data gathering and everything ready for that FMEA session, about 6 months in advance. And
Mm.
when you go to that level of detail and you can sit there and go, here's the evidence, here's the data, it's irrefutable. Here's the detection method, here's the design. And you can sit there, in your warranty process, or you can sit there with your OEM and go, look, there's clear benefit here. We've identified the problem. We've got the detection method. Here's your data. You need to do something about this. And having that power of data, it's an enablement tool.
100%. I've always said FMEA is the catalyst for all of this great work that we do. Like it targets your subsystems, your components, you break it right down, and then you start really pinpointing the technology to truly eliminate or reduce your diagnosis path and your failure. So I totally agree with what you're saying. Like think of FMEA as a catalyst. It's a lot of work, a lot of prep, a lot of doing, a lot of work afterwards, but it's worth the effort.
I tell you something, it would be some terrible superheroes. Be criticality in UFMEA. God knows what them outfits would look like.
Mhm.
So, kind of closing out, what changed for us and the teams we supported when we detected degradation earlier? Before the impact, that there's a load of benefits. What was you seeing?
I think you could roll all the benefits I'm going to list up to time. I think time was what you got out of this shift from reactive to I'll say predictive. So you turn from a firefighter to an engineer. You can say reactive firefighting there. And then this is mentioned a lot of times, like these technicians who have got such good expertise, they've been with the armed force, or they've been with through apprentices and heavy manufacturing, wherever they've come from. they've got so much expertise in terms of the engineers, but the technicians that can do they're a Swiss Army knife that can do all sorts of things, and they get really disheartened coming into a business where you're just putting fires out. So I think a lot of places in the early days that's what you're working with because you're just starting the engines really. So that's certainly for me. So I'll go from time. But then what comes from that is you enable people, so you start unlocking potential. That senior technician that you thought was great at changing a belt is now great at leading a criticality assessment or globalizing a predictive maintenance program. So you unlock the potential. Um, you also had a more calmer atmosphere, and what comes with a calmer atmosphere is less stress, which means less safety incidents. And that might seem a little extreme to say that it helps safety, but I think just having a calmer environment where people are thinking logically, you're giving them the tools and the systems to do the job more efficiently. So all these things that are listed, I would roll up into time, and then not just the technicians. We keep mentioning technicians, but planners and schedulers. They can be super stressed when they've got this maintenance activity to plan in, and their availability isn't there, and they've got parts in the stores, working capital, they're losing money, like all these things. It's such a knock-on effect. So for me, that's what changes when you detect early, but also your asset loves you. If you love your asset's gonna love you back. So if you're looking after it before it breaks down, fault confirmation, reduced downtime, all these things that are listed. So yeah, that's what I'd explain. My viewpoint on detecting early, what it gives you.
I I always find it quite funny because engineers and technicians are quite emotional people. We
Mm.
don't like things when they break. If anything, it ruins my day. And the fact that, we talk about giving time back, it allows me to go and do that fix properly so I'm not coming back next week. If I fix something, I don't want to be back. Oh, it's one and done with me. Right, first time, leave. And it's kind of where, we touched on MTTR earlier, but when you take that mean time to respond, there's another part to this is mean time between failure. Like if you're got a really slow or a really good mean time to respond, and you're doing everything in 20 minutes, but your mean time between failures every 20 minutes, are you actually
Yeah,
effective? No.
yeah.
So when you enable engineers with the predictive and corrective technologies, and you've got that live monitoring, and they've got time to go in and do the root cause analysis correctly, the repair's done, operations is saved. It's the aftermath now. It's the after reporting. It's getting back into design. It's making sure it doesn't happen again. How do we make everything out more reliable? And you get back to that point where I'm designing for reliability or I'm designing for maintenance. What time's key. If we're not effective with our labor and we're not in the right place at the right time, we're not going to be able to free our labor up to do the good work.
Precisely that, and that's why I think rolling it up as time and explaining it as that is the best way to do it. There's a lot more than what's on the screen in there, like your relationship with other functions, like your relationship with operations becomes better and others as well, IT. So yeah, it's a game changer, and I think you can see there from red to green what happens when you bring these systems in.
That's it. But considering the vast landscape you've worked across, what are the best practices you've seen affect on the shop floor? Like if any of the people on the call today could walk away tomorrow and take a few learnings away and just make, that you've seen real value from at the shop floor level.
Mhm. Yeah, there's many things I've seen that as we change. Yeah, probably we mentioned asset criticality already, but it's super important if you don't do that assessment from the get-go, and it can and different factors can affect different industries and facilities. So I think core to criticality assessment is health and safety. Like, what's the worst case scenario if this happens? Can people get hurt? So I think that's always number one. The cost, what's the cost of this going to be in terms of spare parts and labor hours? Like, how many hours is it going to take us, how much downtime we're going to have. But environmental, I used to work on a chemical site next to a water course. It was next to a river. We had chlorine and acids and nasty things. So environment was always top. Regulatory in pharma and FMCG. So I think you've got to tailor your scoring system, but it's key to do criticality. And then your strategies become much more fluid. If you don't do criticality, I think we've all done it. You spend months and months on an asset that after it you don't get your bang for your buck, and then your ROI is not there. So there's so much comes from that. Um, Targeted failure modes. We've mentioned failure modes a lot, but the beauty of having a multidiscipline team in the room is, if you've got automation engineers, you've got mechanical engineers, whatever they may be. You brainstorm together. I used to love that part of the FMEA. Like, it's repetitive. You've got to put the work in, but when you get to the point of going, right, the risk priority number is really high here. How do it? And then the room kind of comes alive again. So I think a line detection on failure modes. Sorry, two failure modes. Continuous visibility. No one likes the visibility gap. No one likes hidden metrics or hidden anything. No one likes a surprise either, really. So um, it changes that. So monitoring change over time reveals degradation earlier. Yes, everyone's got a much calmer morning if you can see what's going on rather than guessing what's going on. Um, FMEAs should be live documents. I think criticality assessments as well. If you so risk priority number, occurrence, detection, severity, you rank your RPNs, and then you go back after 6 months once you've done the action, and you should be reducing them RPNs. So I think it's key to have a living. It's not just manuals and specifications that should be live documents. It should be FMEAs. Culture is probably the similar to what we said with time. It's probably the overarching word to use is adoption, proactiveness, like people buying in. It's not just a one-off thing. Like, it's not a project that you do and it's finished. It's a day-to-day. You live and breathe it. It's fun. It's your fundamentals and uh, WCM, world-class manufacturing. Like we've seen it in our previous lives. Like, if you get your pillars of WCM right, okay, but you shouldn't be just getting ready for your audit. You should be living and breathing it, and your audit becomes easy then. You don't have to get stressed for your audit because you're doing what you should be doing day to day. So yeah, there's many more as well, but I think they're the six that stand out.
So yeah, I absolutely love them, Sean. I think the one that really resonates with me there is living documents, and it's not even that it's attached to FMEA or criticality. I've visited sites all over the world, and I'm going to use it. I'm going to say the word again because apparently I love it. Criticality, and yeah, I've done it, but they were still struggling fundamentally throughout their site. And it weren't until I actually realised, and I went back and looked through that criticality instead of taking the word for that did it. It was 4 years old. And at the time, all the right intentions were there. They spent that first year, they were getting there, everything was solid. They were using that criticality assessment to know drive detection methods, drive continuous improvement programs, and they worked. But what the problem is then, a year later, when the severity and the occurrence and the detection methods added all that caveat to the RPN scoring, they didn't revisit it. So they were still focusing all that labor and resource on assets that they covered for the next 4 years. And all these things that were at the bottom ticking over, no longer getting any of that attention, started creeping back up. So actually, if they would have gone back, looked again, and reassessed, all
Mhm.
these assets would have been covered again. So living documents is a great one. And to be honest, I really enjoyed this chat. We'll have to do it again.
Yeah, me too. Um, I love the world of reliability. I think so many things we
Great.
can do, and then the world's changing. We've got AI coming in strong, so we've got to utilize that as well.
So many changes, but let's get into our final takeaways. So, failures aren't sudden. Signals just weren't detected in time. Traditional monitoring sees states, not degradation. Visibility gaps, not a lack of data, drive risk. And leading operators optimize where they detect on the curve. And then we will This is a bit where you can find us. We help reliability teams close the visibility gap by unifying thermal, vibration, and environmental sensing and analysis into a single condition intelligence platform called MSCI Connect. There will be some links and that in the chat where you can go and have a look for yourself. And then that will lead us nicely to Sean. It sounds like they want an encore, so we're going to get into some questions. We'll give you a minute
Let's do it.
while these questions start coming in, and then I'm going to do that old people thing where I got to get really close to the screen to read which questions are coming in. Right, which one are we going to go for? Let's go for, here we go. How do you recommend teams balance fast, mean time to repair with doing the right long-term fix, especially when throughput pressure is high?
It's a really good question, that one. I think there's pressure from every angle for mean time repair. Like nobody likes things to be down for too long, but you should, well, first of all, check your next availability. Like I don't think there's anything wrong in putting a short-term repair on something if it's safe and it's operational. If you can quickly after that go and remediate and bring it back to standard or improve it even more. So I think always, try and keep your MTTR small as possible. But what comes through that is, training, spare parts, your method statements, your risk assessments, all these different things build up to a better MTTR. But look at your availability, like don't panic. Like a short-term fix is okay, but have you got a shutdown in 3 weeks where you can plan in and go, we're really going to bring that back to where we need it to be? If you haven't got availability, then increase your preventive maintenance, like increase your trending in terms of your frequency. So if you were, I don't know, if you were doing a 4 week check, bring it to 1 week, keep a closer eye. If you've got infrared predictive techniques, then rather than looking at daily, maybe looking at every hour. So just put things in place so you can hit both a short MTTR and getting it back to where it needs to be.
I think this is a two-part question, because if we look at MTTR, I've never looked at MTTR on its own. Like without mean time between failure, you're getting half a picture. So if you're looking at mean time to repair with doing the right long-term fix and trying to balance that, mean time between failure is going to do that. In fact, we kind of touched on it a minute ago where it was like, if your mean time to repair is 20 minutes, but your mean time between failure is 20 minutes, what are you doing? At some point, you've got to accept the downtime. If you get to the point where MTTR and MTBF are equal, you're fighting against the tide. It's not going to happen. At some point, you've got to have that conversation with operations and just step back and do the fix right first time. Because all that tinkering you're doing in between is where we get back into where we're looking at OEE with them micro stoppages. It's not helping anyone in the long term.
And that's it. Like it depends. Also, we say short-term fix, but what does that mean? Like if you look at the risk of failure happening again, you can go and have the conversation with operations. Now, if you're putting a piece of gauze over a broken acid pipe, then that short-term fix isn't going to fly. But if I don't know, you've come up with a different way of fixing a roller in place or something like that, where okay, what's the risk here? Like, what's the risk assessment? Is someone going to get hurt? Is it going to take us down for a long time? Like, so just be, I guess, flex to what the situation is, because calling it a short-term fix doesn't mean it's the same situation every time.
Should we go for another one?
Yeah, let's do it.
Plenty of time. The only problem is I can't see the names, but I'm going to go with. They're trying to call us out on this one, Sean, considering how much we've mentioned it. How often should teams revisit FMEAs or criticality rankings once operations change?
I'm going to split the answer to that. I don't think there's a set frequency. Like I always went on this every 6 month mark, but that's when your FMEA is done and you've got your action list. You've assigned the actions. Go back every 6 months. And where are you with the action? Is it done? Is it progressed? Can you reevaluate and rescore your RPN? But then again, it shouldn't be a set frequency. It should be as and when. So yeah, in an FMEA, you definitely look at the known failure modes that you've seen and you brainstorm potential failure modes, but we're not perfect. So you'll always see a failure crop up in the future where it's not on there. Like it should be, if it needs to be weekly, then it should be weekly. If it needs to be daily, it should be daily. Hopefully, it won't be daily, but I don't think there's any set frequency to say there's an industry standard that says you have to do it at this interval. There might be something out there, but I would say definitely 6 months on your actions or even tighter, dependent on the criticality. Um, and then as and when, like it's live for a reason.
Dynamic, isn't it? So, you know, I spent time running a program where we could do live automated criticality assessments. And if you got that kind of level data we had, like I said at the time, in the early days, we were data rich, wisdom poor. And as we progressed and our maturity started to grow, we became a little bit more wisdom rich. Wouldn't say we knew everything, but we started asking ourselves questions like, you know, what else? What else could we do with that data? When we used to look at like the data driven maintenance initiatives we used to do, is what else could I use that data for? Could I use it to automate my criticality? It's the same with your FMEAs. If your FMEAs are living documents and they're feeding off your CMMS, they're feeding off your asset condition management systems, if they're feeding, you know, through all your work order history and understanding them failure modes and they're auto-populating in there, or even some at work, you've just got them done a massive continuous improvement program. That continuous improvement program should affect your criticality, should affect your FMEA. They all feed,
Yep.
they're all intermingled through the same KPIs.
Yeah, they're intertwined, and you mentioned earlier, like them not being live documents. I think we've all got short memories. Like I always take the stance that at that moment in time you were working on that topic or whatever it was, or that request, because it was important then. So at some point in the future it could be important again. So don't have a short memory. Like go back to what you've done and iterate and improve. I think time's always a thing. Every business has pressure and our priorities change day to day, but stay organized and keep going back to what you've done. If it's a manual, if it's a preventive maintenance plan, if it's UI UX or whatever it is, keep going back.
Sean Allen's tip of the day: don't be a goldfish.
Don't be a goldfish. Don't have a short memory.
Okay, let's go for another one. How can I get my executive team on board for a continuous condition monitoring program?
Mm.
Now, isn't
Everything
this a
we've said
big
in this,
question?
show them this webinar, and then that'll help. In all seriousness, I think at that level they want to see ROI. So you've got to prove the worth of the investment in terms of like case studies, like shows numbers, shows how many detections have been detected, how many failures have been avoided, what is the potential missed downtime or whatever metrics you're tracking. I think, but also treat it as a package. Like you should never just bring in a camera or a sensor and just install it and think that's it done. Like prove to them that it's a program, it's a package that there's going to be training, there's going to be software, there's going to be a dashboard. We're going to bring the hardware and the software, and we're going to treat it as a program rather than just a technique. I think there's that many off the shelf things that you can go out and buy. Make sure that you're explaining the full story, like and show some evidence.
Yeah, I've done a lot of these in my time. I've written too many white papers that I care to count at this point. It's almost like an engineer when you're trying to run these programs. You have to be, you know, bilingual. Got to
Mm.
speak finance. These programs are multi-stakeholder programs. You've got finance, you've got networking, you've got supply chain, you've got operations buy-in. And if you can't speak to all the benefits of these individual stakeholders, they're not
Hmm.
going to care. This is why if you go through my LinkedIn and things like that and other webinars I've done in the past, I always that there's one key point that always sticks to me that reliability isn't a program. It isn't one person. It isn't, a single technology. It's a stakeholder of people. It's a consortium of different diverse backgrounds and job abilities and responsibilities. And if you don't get all them in the room, you're never going to get buy-in. What you're doing is you're trying to push someone uphill and hope someone that likes it.
Yeah, I agree. I think bilingual is a great word for it. Speak to their world and speak their requirements. So yeah, I think that's it. It's been great speaking, Luke.
Yeah, I loved
Really,
it
really
and I
enjoyed it.
enjoyed it. And thank you everyone for attending.
Yes, thank you to you both. That felt like a really terrific discussion. So I hope that all of our attendees here, judging from the questions as well that have come in, everybody seems to have really enjoyed your presentation. So for everybody that remains, please do come in and visit our website, and you're welcome to book some time to meet with our team here, including those that you see here on our screen, to discuss how we can help you implement some of these best practices for condition-based monitoring. So thank you all and have a great day.